question 4, June 08, paper 2. So there's another paper 2 question, question 4. Circuit breakers are used to protect the users of electrical appliances from receiving a shock. The diagram below shows the structure of a circuit breaker that uses an electromagnet. So a lot of these circuit breaker circuits are shown using electromagnets. So you've got a coil of wire here around an iron core. You can see there's a complete circuit here with a power supply connected over here, of course. You've got a complete circuit the way that's sitting at the minute. And once the current is switched on, then this iron core becomes a magnet. So it says, mark with an arrow the force that the electromagnet exerts on the iron arm, which is this bit here, when a current flows in and out of the circuit breaker. Label this force E. So it's going to be attracted down, and it's a capital E like that. On the diagram, mark with an arrow the force that the spring exerts on the iron arm. Label this force S. So this spring's stopping that from moving up, and so I'm going to label it S. Now, if you don't label it, you won't get your marks. There's 2 marks there, very easy marks. If you don't mark them and label them, in particular label them, they won't give you the marks. The circuit breaker will switch off the current when it exceeds 15 amps. Describe what happens inside the circuit breaker that causes the circuit to be broken when the current exceeds 15 amps. Now, at the minute, there's a balanced moments idea going on here with the iron arm, that the moment on this side is equal to the moment on that side. This is exerting a force on that, but it's just enough force to keep it in that position. But once the current exceeds 15 amps, this electromagnet becomes stronger. This force attracting the iron arm down becomes bigger, and the iron arm is going to move down. So we've got 3 marks, and we need quality of written communication here. That means you must write in complete sentences with proper grammar and spelling. I'm just going to write in bullet points here, but you're going to write it properly, and unless you make a complete mistake there and write about something completely incorrect, they'll give you your 1 mark. So the first thing there then is, once the current exceeds the 15 amps, the magnetic field of the coil increases or becomes greater. Then they suggest in the mark scheme that you might write something about moments. So you could write that the anti-clockwise moments, which is this side here, I'll show you there, there's the anti-clockwise moment there, becomes greater than the clockwise moments, which is the moment due to the spring. And therefore the iron arm is attracted to the coil. This breaks the contact. So if you see there, once this is moved down, this contact is broken. And then the last part then, the circuit is broken. Now, they would really only give 1 mark for either of those. So there's 1, 2, 3 and 4, and they say 3 out of 4 points there. Right, the circuit breaker is to be modified to allow it to break the circuit for currents just greater than 5 amps. So we were talking about 15 amps up here, they're only talking about 5 amps. Should the springy metal be made stronger or weaker? Now that circuit will always work provided that this is balanced. If you want this to break whenever this is only 5 amps which is flowing through the coil, you want that to be able to move down at 5 amps, so that you have to make that springy metal strip or this springy metal part much weaker to make sure that it allows it to move up whenever this is only 5 amps. So the answer down there is weaker. Part B of question 4, June 08, paper 2. The diagram shows an AC generator. What happens in the coil of wire when the magnet rotates? So here we go again about this changing magnetic field. So you'll have a changing magnetic field as the magnet's rotated. It's continually changing direction. So what you're going to say there then is that current is induced in the ammeter. But because it says rotates there, you have to explain that it's going to rotate one direction. The meter is going to go one direction, then the other, as the coil is rotated. So in one direction, and then the other. And that's going to give you your 2 marks, one for saying current is induced, and then a second mark for saying change in direction. You could say from plus to minus. There. What's the name? There's that 1 mark again for that name. It's electromagnetic induction. We're just going to write electromag induction. Now, if you're not sure, is electromagnetic induction going on, you look at your circuit with the meter in it and see if there's a power supply in it. If there's no obvious sign of a power supply, then if there's current being flowing through there, it has to be electromagnetic induction. And you'll see there's some kind of change in a magnetic field, whether there's a magnet present or not. It might be an electromagnet that's been switched on and off. The sensitive ammeter is removed and the ends of the coil are then connected to a cathode ray oscilloscope. So this is a screen with a grid on it and you'll see a green line appearing on it. It says draw the trace that might be seen on the cathode ray oscilloscope. So we're going to draw an alternating current because we know that it's going to be in just one direction, then the other as the magnet is rotated. And so we're going to draw something like that. So that's one cycle, we'll do another one. And then it says, how is the output from the AC generator different from that obtained from a battery? This isn't just a matter of saying that this is an alternating current and a battery produces direct. This statement's really saying what's the difference between alternating and direct. So alternating current continually changes direction. So there's that definition coming in again, continually changes direction. From a battery you get DC and it only travels in one direction. And that's your 2 marks. Now you see when it says something like compare, explain when something is different, you must say about both things. You have to explain both of them. And it's very easy to work out where those 2 marks are going to come from. One description of alternating current, one description of direct current.